Good morning. How you all doing today? Excellent. Even if your answer was bad, make it a little bit better. So today, we're going to go on to something that's like the end all and be all of geometry. Like every single person remembers what we're doing today. Okay. It's called the Pythagorean Theorem. Very, very common. All right. A lot of people know about it. So let's get started. So the latest scandal is that Pythagoras got caught in a love triangle. Yes, the Pythagorean theorem deals with triangles. Okay. The next one, this one's kind of comical. If you notice that Pythagoras and Mr. Einstein here are fighting over the c squared. You'll see what that is in a few minutes if you're not sure. So who is this Pythagoras guy? Well, he's a Greek philosopher and a mathematician. Okay. And he was born a long, long time ago, 570 BC. Right. So if we're in 2020, we're looking at 25, almost 2,600 years ago he was born. He died somewhere between 500 and 490 BC. They didn't really have good, accurate, very good records back then. So that's the best estimate they have. It is what it is. So what is it that this guy has done? Well, he helped us to understand a little bit about the right triangle. And there's relationships that happen within the right triangle. So this is what he came up with. I know, you're a little confused. Well, this is a leg. This is a leg. And if you look at what this says, it actually says hypotenuse. 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 Yes, that is what we have when we deal with a right triangle. So with right triangles, there's obviously two lines that make up the right angle, and then you have the side that's opposite the right angle. So the two sides that are formed to make the right angle are called the legs. The side opposite is called the hypotenuse, hence hypotenuse. Okay. So hypotenuse is Greek for stretching under. Okay. Here it looks like, oh, well, you're over it. Yeah, possibly. If I rotate it, I'd be under it. Okay. So the hypotenuse is always the side opposite the right angle. So here is the right angle. What you do is you go opposite. Okay, you go travel across through the center, well, not necessarily the center, but the inside of the shape. And then when you reach the other line on the other side, that's called the opposite. So the opposite of this angle would be that side. The opposite of this angle will be that side. So the side opposite of a right angle is always called the hypotenuse. And we said, like on the last slide, that the two legs form the right angle. Now, it doesn't matter which direction that the triangle is oriented. So if you look here, the right angle is here, so the hypotenuse is there. If you come here, here's the right angle, so the hypotenuse is there. This one, the right angle is here, so the hypotenuse is there. So the one thing you always look for, and I don't have them in this one, is you always look for that little right angle sign, or symbol. So that way you know where the right angle is. Go across it, you'll find your hypotenuse. What is a Pythagorean theorem? Okay, well, first let's come up with what in the world is a theorem. In mathematics, it's just a proven rule. So next year when you guys are doing geometry, you're going to be doing a lot with theorems. All right, it's going to help you to understand different parts of geometry, help you to prove things, help you to think about different things. So a theorem just means that it's a mathematical concept, it's a rule, but it was proven through some kind of reasoning. You'll do more of that next year, like I said. So on a triangle, in a right triangle, we dedicate the legs to be letters A and B. And it doesn't matter which one is A and which one is B. We just say that one of them is A, one of them is B, just because they're different sides. That's all. Okay, so it doesn't really matter which one you choose. C is always going to be the hypotenuse. Okay, so legs are A and B, hypotenuse is C. Okay, we take the square of the first leg and the square of the second leg, and we add those together. When we do that, we will get the square of the third leg. Okay, So we just use the formula we say a squared plus b squared equals c squared. Okay, but that just means one leg, you square it, add that to the second leg squared, and that will give you the third leg. Now this doesn't use a, b, and c, but I used it because I like the actual number of squares you see in here. So the length of this one is 3. So if I square 3, I get 9. This one, if I square 4, it's a length of 4, I get 16. Well, what's 16 plus 9? It's 25. And this length right here is 5. So if we were in school, we actually would have done this on a piece of grid paper. We would have measured out 3 squares and then 4 squares. And then when we connected it this way, based off of the number of however long the grids, the actual boxes are, it would have been a length of 5 boxes here. Now, because it's a diagonal, it's a little hard, but we would have been able to do that and you could have seen it. Yeah, it would have been fun. Okay, so how do we solve this? So a squared plus b squared equals c squared. So 3 squared is 9 plus 4 squared is 16. That equals 25. Well, we use it to find one of the 3 sides. So just kind of gives you an idea of why it works. Now we're actually going to do it. So we're going to use the formula a squared plus b squared equals c squared. So we look, okay, these 2 sides form the right angle, therefore they are the legs. So it's going to be this side squared plus that side squared, and that's going to equal that side squared. So 5 squared plus 12 squared is going to be c squared. So 5 squared is 25. 12 squared is 144. 25 plus 144 is 169. That equals c squared. That doesn't equal c. So like last class, we take the square root of the numbers. Square root of 169 is 13. Now, I know last class, when we had a variable, we said positive and negative. Now, this is one of those situations you can't have a negative because there is no negative distance. It's always going to be a length, so it's always going to be the positive number. So in this case, we just take the positive number. So it's 13. So this length right here would be 13 meters. So you could actually do this, and it doesn't have to be meters. It could be anything. So like if you take a ruler and you make a 5-inch line, and then you make a perfect 90-degree angle, and then you make a 12-inch line, the distance from that point to that point will be 13 inches. It's kind of cool. Try it if you want. Now let's go to the Jamboard to actually do a few of these. All right. So this one is like the one we did last time. Okay, so it's 8 feet, 15 feet, and then we don't know the hypotenuse. So again, it doesn't matter which one we use for A and B. So we'll do 15 squared, which is that leg. Now we do the next leg, which is 8 squared, and that's going to equal the hypotenuse squared. So 15 squared is 225. 8 squared is 64. And that's going to equal c squared. So what's 25 plus 64? I don't know. Let's go to a calculator to find out. No reason to calculate that in your heads. 25 plus 64 is 289. So 289 equals c squared. Now we take the square root of both sides. It's nice about the calculator and the phone. You just turn it sideways and you can do that. That comes out to be 17. So I'll just write it up here so you can see it better. C equals 17. So the correct answer is 17 feet. Okay, so we found the numbers we have. They're legs because they form a right angle. So those are your A and B. Plug it in and solve. Plug and chug. Now, you don't always have to find the hypotenuse. Sometimes they give you the hypotenuse, and you have to find one of the sides, okay, or one of the legs. So they tell us this one happens to be A. Again, the variable doesn't matter in this case. The only one that truly matters is your hypotenuse is C. The other two don't matter. So it's A squared plus B squared equals C squared. So they tell us that's going to be A. So A squared plus 2.1 squared equals 2.9 squared. So A squared plus, I think that's 4.41. Yes, plus 4.41. That equals 2.9 squared, which is 8.41. Now we're just going to do a simple algebraic equation. We're just going to solve for a. So what am I doing? I'm squaring it, then adding 4.41. So I just subtract my 4.41 from both sides. I'm going to come to the side over here just so it's a little bit easier. So a squared is, that minus that is 4. Well, to find a, I take the square root of both sides just like we did last time. A equals 2. So this would be 2 centimeters because that's the units we have. All right, let's do one last one, and then you guys will be on your way for this one. All right, so a squared plus b squared equals c squared. So they're telling us this one's b, fine. Okay, so the other one's going to be a, so 16 squared plus b squared equals c squared. Oops, sorry, not c squared. It is c squared, but it's going to be 34. Okay, squared. All right, so 16 squared, I don't know that one off the top of my head. Oops, helps if I type in the right number. 256. So 256 plus b squared equals, I think this is 1156. Yes, equals 1156. Oh, now I need to solve for b. So since I'm adding something to it, so I square it and add, so I need to subtract first and then do that. Do the squared part. So that's b squared equals 900. Because 1156 minus 256 is 900. Take the square root of both sides, and b is 30. So the correct answer is 30 yards. Okay. Now, these ones, each time we did it, it came out to be a integer. They don't always have to come out to be integers. You might have one or two that come out to have a decimal, just like here. Okay, so let's say I did 2 here and 2.1 there. It would have came out to be 2.9. Not that big of a deal. All right, so they're not always going to be perfect integers. They'll get a little bit more complicated in a couple of days, but we'll see what that is. So this is just the first part of the lesson. I just broke it up. We're going to change it up slightly for the next class, but I thought this was a good amount for one day. So good luck on your assignment. Please reach out if you need any help. Bye.